Having talked about equality of vectors and transmissibility of vectors, let us now see how do we add and subtract vectors using our graphical method. This is more or less a review, because I am sure you have learned this in your 12th grade. So, if I want to add two vectors A and B, what we do is, so we are doing A plus B, what we do is take A, on its head put the tail of B, and then draw a vector starting from the tail of A to the head of B, and that gives you A plus B. You may ask, why do I add this way? Does it make sense? It certainly does. Suppose there is a ball moving like this with velocity v1, and I hit it so that it acquires a velocity v2 in this direction. Experience tells me that it would be moving in a direction like this, which would be a sum of v1 plus v2. You see, I have added v1 and v2 using the prescription I just gave you. I draw v1 and put the tail of v2 on the head of v1, draw this vector, and this gives me v1 plus v2. So, this is how we define the addition, or we obtain the addition of two vectors. It is also easy to see that addition of vectors is commutative. That is, A plus B is same as B plus A. Let us see that. So, let there be a vector A and let there be a vector B, then this is A plus B. On the other hand, if I draw the vector A with its tail at the head of B, then this would give me B plus A. But this arm is parallel to this, because this is a parallelogram. So, these two vectors are parallel, and because this is a parallelogram, this magnitude is the same as this, and this implies A plus B is the same as B plus A. So, summation of two vectors is commutative. You see, graphical method is giving you a very visual way of looking at vectors. Next, we can use addition of vectors to define the product of a number and vector. For example, if I take A and add A to it, you can easily see that the length becomes doubles, and therefore, its magnitude is 2A, and since it is the same direction as A, I can write this as 2 times A vector. Similarly, if I add 3 vectors, the magnitude would become 3 times A, and it is in the same direction as A, therefore, I can write this as 3A. So, this defines the multiplication of a number with the vector. It is nothing but adding that vector that many times. How about 1.5A? 1.5A would be A plus half the magnitude, but in the same direction. So, this would be A, this would be 0.5A, and their addition gives me 1.5A. Can I multiply a vector by a negative number? The answer is yes. So, product of a negative number and a vector. Recall from your school days, what does multiplying by a negative number mean? If I go to number line, this is 1, 2, 3, 4, minus 1 is in the other direction, minus 2 is also in the other direction, minus 3 is in the other direction, and so on. If I multiply minus 3 by minus 1, it becomes 3. So, minus 1 times minus 3 becomes 3. What the multiplication by a negative number is doing, therefore, is changing the direction. Similarly, if I take negative a, which will be minus 1 times a, this would be nothing but changing the direction of a. So, if a is this, minus a would be pointing in the other direction. That is the meaning of multiplying by a negative number. Of course, once you define multiplication by minus 1, you can define multiplication by minus any number. You just make it that many times more. Having obtained minus a, it is now very straightforward to subtract vectors. So, how do we do subtraction of vectors? Suppose I have to subtract b from a. This would be same as a plus minus 1 times b. So, what do? We take vector a and I want to subtract b from it. This would be the same as taking a and adding minus b to it. So, a minus b would be a minus b would be this. This would give me a minus b. And you can see right away that a minus b is not same as b minus a, because b minus a would be b minus a. Minus a would be opposite to a, and therefore, this would be like this. This is b minus a. So, you can see that a minus b is not the same as b minus a, but through graph you can see very easily that a minus b is equal to minus of b minus a. So, what we have done is addition and subtraction of two vectors. Similarly, if you have to add 3 vectors, you can do a plus b, then add the third one to it. If you have to do 4 vectors, you can do a plus b, c plus d, add the 2 resultants again, and so on. Let us do 2 examples showing the summation of 2 vectors and subtraction of 1 vector from the other. So, example 1, suppose there is a person who walks 300 meters to the east and then 400 meters to the north. We want to ask what is the total distance he covered. This is obviously 700 meters, and then we ask what is the vector displacement which is a vector quantity of the person from the original position. To get that, we have to add the 2 displacements vectorially. So, suppose the person started from here, he moved 1, 2 and 300 meters to the east, and then 1, 2, 3, 400 meters to the north. So, this is his first displacement up to this point, and then second displacement from here to here, and therefore, the net displacement would be in this direction. This is 400, this is 300, and therefore, this would be 500. So, net displacement of the person is 500 meters, and in which direction? at an angle theta, where theta is going to be tangent inverse of 4 over 3 from the east towards north. So, this is his net displacement. This is how you would find the addition of two vectors, and which gives you the magnitude and its direction. In the second example, let us take the case of two persons pushing a box. So that the net force F net is, let us say, 12 newtons to the right or to the east. One person applies a force F 1, which is 5 newtons to the north. We ask what is the force applied by the second person. Let it be F 2. Then we know that F net is going to be equal to F 1 plus F 2, and therefore, F 2 is equal to F net minus F 1. F 2 is equal to F net minus F 1. We have been given that F net is 12 newtons to the east. F 1, this is F net. F 1 is 5 newtons to the north, and therefore, F net minus F 1 is going to be, this is F net minus F 1 will make going to the south, and this would give me F 2. You can see that F 2 is going to be 13 newtons, because this is 12, this is 5, at an angle theta equals tangent inverse 5 over 12 towards south from the east. So, I have given you two examples, one in which we added two vectors and one in which we subtracted one vector from the other.